what's brought many of you here today, and I believe this is probably what you know Dr. Lovelock for. He is the originator of the Gaia hypothesis, which is now known as Gaia theory, and he's written a series of books on this subject. His latest book, The Vanishing Face of Gaia, is going to form the basis of his talk today. And with no further ado, will you please help me in welcoming Dr. James Lovelock.
Where we live in the United Kingdom and in much of Northern Europe, the summer last year was cool and wet, as it often is in the UK, and the winter so far has been the coolest of this century. And according to quite reliable climate scientists around the world, the Earth's average temperature fell by about 0.5 degrees Celsius last year. So, does this mean that global warming is no more than just a green nightmare, and we need no longer fret about our carbon footprints? Well, the climate skeptics think so, and I think I would, and I expect many of you would like to agree with them and be quite relaxed about climate change. But sadly, the facts, despite the present cool spell, do not justify such an optimistic conclusion. Importantly, the IPCC regards climate change as real and potentially deadly. Their findings are taken up by world leaders as authoritative, so much so that their predictions are used to frame legislation and policies looking as far as the middle of the century. Governments and the UN and other agencies are also prepared to hold grand meetings like those at Kyoto, Bali, and the one soon due in Copenhagen. And their assumption, all of them, is that global warming is so serious that massive and expensive action is needed now if we're to avoid damaging climate change in the future. Now, there aren't any certainties in science, but if we see the IPCC's reports from the Earth's viewpoint instead of from a human or a United Nations viewpoint, far from underestimating, they become, I think, one of the scariest official documents ever to have been presented. The Earth doesn't just accept what we do to it, it responds to climate change, and that response is far more deadly than the small change that we ourselves have made. I often think that our position is a bit like someone who goes out for a walk in a forest and finds a gun that's been left and doesn't notice that it's loaded and accidentally pulls the trigger, kills somebody or does some kind of damage. It was an accident. It was never intended, what we did. And that's how we should look at it. All feelings of guilt, I think, are quite inappropriate. Because the changes to the Earth system are now happening in the deserts, the forests, on the ocean surface, and in the Arctic, all far away from the cities, we don't notice them. But they bring to me an apocalyptic view of the future, because I see as a consequence of the changes 6 to 8 billion of humans faced with an ever-diminishing supply of food and water in an increasingly intolerable climate. And this grim view of our future is shared by such eminent scientists as James Hansen and Steve Schneider. You may well ask, how have we scientists let so potentially disastrous a future steal up on us unawares? Well, there are several reasons, and I think one of them is our great success in solving the important but much more manageable problem of stratospheric ozone depletion. You'll all remember about the threat to the ozone layer that occupied our minds at the end of the last century. I expect that our success in solving that one gave us a false confidence in our ability to deal with the far greater and much more complex danger of global heating. But another reason for the slow recognition of the threat of adverse climate change is the division of science into almost totally unconnected specialties. Climate science is almost solely in the province of atmospheric physics and chemistry, and the ecosystems of the Earth, in a similar way, are almost wholly in the province of biology. The Earth itself isn't divided in this way, and so long as we treat it as two separate entities, the geosphere for the material Earth and the biosphere for life, we'll never be able to understand the forces that affect the climate of our planet. But there's a third division that prevents understanding, and that is the old one between theory and practice. The advent of powerful computers towards the end of the last century has made it ever easier to build apparently realistic simulations of our planet, its climate, and its ecosystems. So as a consequence, it becomes quite tempting to believe that the computer model is the real world, and that the hard, down-to-earth effort of gathering data from places like the polar glaciers or the tropical forests is no longer needed. And nothing could be further from the truth. We should have been warned. The first inexcusable error occurred in the 1980s, when the modelers of ozone depletion were so sure that their virtual worlds were real that they ignored data about the CFC abundance in the atmosphere and about ozone in the stratosphere. There were Earth-orbiting satellites that first saw the ozone hole, but the modelers took this finding as an instrument error because their model said there couldn't be any depletion of the kind the satellites found. And it wasn't until two scientists at an Antarctic base looked up at the sky with a simple spectrometer and saw that the ozone had been largely vanishing from over the polar regions, that we knew that anything serious was happening. And now, in a way, we didn't learn the lesson, and a very similar hole has appeared in the ice that's floating near the North Pole. It's something that was found by observers there, not predicted by the model makers of the IPCC. So the lesson still has not been learnt. We need to understand the consequences of adding greenhouse gases to the air, but just as importantly, the consequences of removing the natural forests for farmland, because each of these acts, not just one of them, disables the Earth system's ability to regulate itself. The IPCC is so far off course that the politics of Kyoto, Bali, and Copenhagen all need completely revising. This disturbing criticism is backed up by evidence gathered by scientists who go out there in the real world and are famous for the high quality of their measurements of CO2, of global temperatures, and sea level rise. Now, the mess of points and the line which is the average through them are the actual measurements of the rise of the sea level of the Earth between 1993 and 2005. And you can see it's a steady, more or less remorseless rise upwards. Now, what the IPCC's models suggest is that green range down below. And you can see that even the most pessimistic of the models, the top one, is 1.6 times less than the amount of melting that's actually happened. Now, sea level is singularly important because it's a thermometer in a way. The whole of the water in the oceans of the Earth is contiguous right around the Earth. So if the Earth is taking in heat more than it's losing, then that water will warm and it expands, and that's why the sea level rises. So sea level is your one true, reliable thermometer for the whole Earth.